this one is changed as the read lock again. Then this is called the downgrade. Okay, downgrade the lock. So you don't have to create a new lock. Instead, you can upgrade and downgrade in the same transaction. That is the lock upgrade, lock downgrade. Combined together is called the lock conversion. So finally, we are ready to define what is the two-phase locking. So two-phase locking is there are two phases, as I mentioned. It's simple, locking and unlocking. Think about just a simple locking mechanism. We have only two transactions, one data item, one single operation. So to access the data, you need to get the lock, get the key, and do something and release the lock. Similarly, locking and unlocking. So locking, however, in the transaction concept, one transaction 1 has a number of operations. Okay? Transaction 2 has a number of operations. So, getting the lock, sometimes it's Y, sometimes it's Z, right? In one transaction, one transaction may access the multiple item and multiple operations. So, simplest way to implement the two-phase locking is you can get all the lock that you need. Okay? Then once you get all the lock, do operation and release. That is the kind of the simple implementation of the two-phase locking. So that is the locking and growing phase or shrinking. Sometimes the acquiring phase and the releasing phase, or sometimes called the locking and unlocking. It's not a big difference. It's the same thing, same meaning, but there are two phases of the two-phase locking. So this is an example of the two-phase locking. Okay, so this is a transaction 1 and this is a transaction 2. So this is a timeline. Okay, so first read lock on Y, read lock on X. So any problem? So far no problem. So you can get the lock of this one. And the read item Y and the read item X. So no problem. Unlock the Y, unlock the X. No problem. And write lock X and write lock Y. No problem because both of them are released. And the read item X, Y, and so on. So no problem. Okay, it can be serialized. However, if you implement such the interleaved fashion, this is called the interleaved approach, which means it's timeline, read lock and read item and unlock, and you can do this one and so no problem. So there are different. However, so if you need to get all the lock, but while the other transaction already acquired the lock, you need to wait. Okay, so it may be forever. So in terms of performance, such a simple the two-phase locking are not practical. So to address that problem, we can consider the different version. The first one is the conservative. This approach is called the conservative approach. Conservative version of the two-phase locking. Okay. Then conservative is a simple but practically not possible because you need to wait until you get all the lock. A lot of the deadlock will be happening. So to address that problem, one approach is a basic. Basic means you can push it. Anyway, step. If this one you can get the lock of X, then do it. And next. And at the same time, if transaction 2 has the operation, do. Whenever you need, you can get the lock and do operation and release and do it. Release. Definitely this, the basic operation will cause to what? Deadlock. Deadlock means, so for example here, transaction 2, 1, and read, same time, read. So this is holding this one and holding Y, but the requesting this and requesting this. Okay, they are waiting until release. So it's keep waiting. So basic approach is simple to implement. You can just proceed the next, but it may cause the deadlock a lot. So we need to address that problem. So to address that problem, do you remember the solution of the deadlock in operating system? Practically no solution in the operating system because it's very expensive. Okay, it's a very expensive operation to resolve the deadlock. So operating system ignore, but the database we cannot ignore such a deadlock situation. We need to address that problem. So do you remember this? Anyone who took or taking the operating system? The deadlock you need to study in this semester. This is part of your final exam. Deadlock prevention, deadlock detection and resolution, and the deadlock avoidance means what? Deadlock prevention means we are not going to enter the deadlock. Okay? Before enter there might be request. Request means like a request. Read request on data item 1. Before that, check whether there exists this one caused the deadlock or not. That's the deadlock avoidance. Deadlock prevention means there are 4 requirements of the deadlock: mutual exclusion, sequential waiting, hold and wait, and the no preemptive. If you allow break one of this, there might be no deadlock. Okay? So we are going to adapt the same idea in the strict version of the two-phase locking. Means we can basically adapt the basic version of the two-phase locking, which means proceed the next. In case this one, any request cause the conflict situation. Conflict means one of them is writing, okay, on the same data item. So for example, this one request y is held by this. It's a conflict situation. In case of conflict situation, we will determine. Conflict means not always the deadlock, but means it's a maybe deadlock. So we need to resolve that. How to resolve that? One of the item will be die. Die means kill the transaction, roll back the transaction. So for example, she is holding her cell phone, he is holding his cell phone. He is requesting the cell phone. I try to call, but she is keep holding. She is still asking his cell phone. So it's a deadlock situation. What will be the solution? We can kill one of them. We can give the phone to her. It's a simple solution, right? Then restart your life. That makes sense? Really? Yeah, okay. So that is the solution of the two-phase locking. Otherwise, we cannot address the deadlock situation. Operating system just give the responsibility to the user. However, database, we cannot give that. Okay? Instead, one of the process is waiting. Another process is the rollback. Then, depending on which one will be waiting, which one will be the die. So, first one is the wait die algorithm. Another one is undo wait. But undo wait is kind of opposite of this one. Okay? So we will discuss about the wait die algorithm. Then there is a transaction. For example, in this case, this one caused the problem, right? Conflict situation. Okay. At this time, we will check which transaction is younger. Younger means probably transaction 1 start the time 10 o'clock. This one start 11 o'clock. Actually, in the system, we do not use the real world clock time. Instead, we use sequence number. 1, 2, 3, 4, 5, 6, sequence number. So this is earlier, this is the old one, younger one. So if this one is older, start earlier, we wait. Give the chance to the old. If you go to the downtown, not downtown, the city, like the metro, there are special reserved seat for the old or pregnant, something like that. We can respect the old person, which is not popular. And mine, the hometown, so I think the 1/3 of the seat in the subway and public transportation always reserved for the either old, the pregnant, and the kids. So it's just sometimes weird. Even though it's a pack of the people, some seat nobody actually take the seat because it's reserved for the old one. So if the transaction caused the conflict situation is older than this, then wait. This one is wait. Otherwise, for example, this is young, okay? Then one of them should be the killed. The younger will be died. Okay? That's the idea. We will see the example later. So that is a strict version of the two-phase locking. Okay? This one explain about the deadlock and deadlock situation with each other. Okay? So for example, read lock and the read item, and read lock, X read item, and write lock on X, which is held by T2, and write lock Y, held by the T1. It's waiting each other. Okay? If we are not sure the deadlock is served, you can take a look at operating system textbook, then you will understand. It's actually from the deadlock management. I'm not going to explain the details of the deadlock prevention, detection, avoidance, whatever. So TS, from now on, whenever you see the TS means timestamp, sequence number. So TS, the lower number means old one. It's a start earlier, right? Sequence number 1 means it's a start the first time. 10 means it's a younger one, recently started. So compare if the TI, always left-hand side, causes the conflict situation or the deadlock situation. So if, for example, in this case, so this one caused the problem at this time. That requires the data item held by the T2. And left-hand side is the transaction caused that the conflict situation. Then compare the timestamp. If this one is old, keep it. Allow. One of them can wait. However, if this one is younger, okay, younger, which means the recently started, we roll back, terminate the transaction. Okay, either wait or die. We will see the example. Opposite way is the old one. If this one is the transaction that caused the conflict situation, is old, we the rollback. Otherwise, the wait. So this is actually the same thing. So we will. I'm going to use another. So this is a summary of the two-phase locking. I'm going to skip this one. I already explained. And in the transaction, I mentioned the lock manager will manage the lock table. This is a lock table information item, lock state, shared and history transaction ID, and so on. This is what I explained. Another table is the transaction table. How many transactions are running? Currently, transaction ID and timestamp. Timestamp doesn't have to be the real time. Instead, it can be just the sequence number. Okay? And the transaction state. So as we discussed before, transaction has active, block, aborted, committed, and so on. So this will be discussed by the managed. And the list of items the locked by this transaction. For example, write lock, read lock on X and Y, the items. Okay. So using this, we already see the algorithm of the lock, unlock, read lock, write lock, and the lock conversion, and wait algorithm. So this is an example of the real database state. left hand side, this is the sequence of the operation. Okay? Sequence of operation. So first time, B1 means, number means transaction. And also we are going to assign the transaction number based on timestamp. Okay? So first one will be 1, second one, the next one will be 3, and so on. And this time not always the B3 start. So no, forget about it. So transaction number is assigned. Transaction number is assigned. We need to manage the timestamp separately. Then there are operation read and write. B means begin transaction. And the E means end transaction. And the item will be inside the parentheses. So first you should be able to understand this operation. B1, transaction 1, start. And transaction 1, read on data item 1. Okay? And next, what does it mean? Transaction 1, write Y, which means log upgrade. From read write to write write is upgrade. And this one, read data item Z. And B3 means new transaction start. Okay? New transaction start. And so on. E1 means end of first transaction coming. Okay? And then B2 start and so on. So now we can understand this. Then see whether this one calls the deadlock on. This one is to preserve the concurrency or not. Using what? Two-page locking the property. Two-page locking the algorithm. Okay. As we discussed, we should manage the two tables. One is a transaction table, another one is a log table. Transaction table manages the information about each transaction, including transaction ID, timestamp, the state of the transaction, like the start, aborted, and committed, and so on. And any item that are the result, the accessed by this transaction will be here. Log table is per item. And the log state, what kind of log? Read log or write log? And the transaction ID, which transaction is hold, and which transaction is wait for this one, and so on. Okay, let's just start. So first, P1, the meaning will be displayed here. The T1, transaction 1 begins. So TS means timestamp. Timestamp is the sequence number, so we can assign the TS here. So transaction 1 and the TS, the transaction is active, it's started. Please follow, then the practice by yourself just one time, then you can understand. Okay? Definitely this will be part of your final exam. This is a really good example to understand that here. Okay, then let's move to the next step. Next step is what? Transaction 1, read on item Y. Read log on item Y by transaction 1. Then what you guys need to do? Update transaction table. Because data item Y is a read log. Okay? It's accessed by the transaction 1, Y. Also create the entry for the log table per item. Log table is per item. So Y, and what kind of log? Read log. Who? Transaction ID 1. Okay? And why this one is 1? Because timestamp is the first one. Okay? Not the, in this case, not the same as the transaction number. The next. So far, no problem. It has only one transaction. And this one means write log on data item Y. In this case, it's an upgrade. Upgrade, you don't have to create a new entry log. Instead, just update write log. Okay? That's the reason we define the upgrade and downgrade. You don't have to create a new one. Instead, just change the state of the disk. It's the same transaction. Right? The next, this is a read log on data item Z. So which means we need to create a new log. Database, transaction table, you need to update another item, Z. Okay? Always check the two tables. So this one, for the Z, read lock, transaction ID 1. No problem so far. Then, the new transaction start. Because it's a multi-transaction system, so another transaction can start. So, T3 starts. So, transaction ID 3, timestamp is 2. Because it's a sequence number. It's not the same as the transaction ID. And active. And no lock yet. Okay, then, what does that mean? Read lock on Y. By what? Transaction 3. So you need to update the, you'd like to update this one, and this one is what? The C, not yet. But the Y is, you need to check the first lock table. Y is a write lock. And by what? Transaction ID. What does that mean? Conflict situation. Conflict means, okay, two lock, either two transactions, T1 and T3, okay? Then the same data item Y is already, one of them is a write lock. So it's a conflict. That may cause, it's not always a deadlock, but that may cause the deadlock. We need to take care. How can we take care? Using wait by algorithm. So T3 caused the, transaction 3 caused that issue, conflict, right? Left hand side, TS of the T3. And right hand side, TS of T1. Check the which one is younger. Whether this one is younger or not. In case of younger, kill it, terminate. However, if this one is older, then we proceed. Okay, one of them keep waiting. Who waiting? Old one waiting, and the younger one will be done. So in this case, it's a young T. Transaction 3 is young. So what is the action? Terminate the T3, kill the T3. So T3 is finally aborted. It's the die. And is there any update on the lock table? No, because that tried to make the conflict situation. Okay. Then, what about this one? T3 is already aborted. Do not update the lock table because it's already aborted. Just aborted, aborted, and then write on Z by T1. Is there any problem? No, it's the same one. So Z is upgrade because the lock table, in the lock table, Z is read lock and transaction 1. So it's just an upgrade, the WL. And finally, end of transaction 1 is committed. So you can change the state. Then what happened lock table? When transaction is updated, you need to check this one. This the column. Any transaction is waiting this. No transaction is waiting. You can just release the lock, which means it's nothing. However, in case something like the T4 is here, then you need to update this TID by the 4, like that. Okay. So this is next B2. So B2 begins. It's a new transaction. It's a timestamp is 3, active, and read lock X, read lock transaction by the transaction ID 2, X, no problem. Proceed, upgrade, and be careful. This one is a transaction 3. Transaction 3 is already aborted, so just nothing happens and aborted. And this is a transaction 2, read lock on the Z. So another item, and the C will be the new entry on the lock table, and upgrade the write lock, and finally T2 is committed. So there might be no deadlock situation. However, be careful, this one does not guarantee the deadlock always. Okay? It may cause the deadlock, so to prevent the deadlock, we are going to terminate one of the process. That is the younger one. So that's the idea of the two-phase locking. There are another exercise. Please practice this one. At least understand this table. The key part is you need to, for each operation, you need to check the transaction table as well as the log table. Okay? Grace, if you try to, we actually use the priority for the timestamp. Okay, we try to give the early, the transaction has the priority to be survived. As we learned a lot in the computer science, any algorithm that is based on the priority, it always has a starvation problem. So for example, if the new transaction start, but conflict and die, new transaction start, die. So that is a starvation. So you need to think about addressing the starvation in the wound weight or weight algorithm. Always a younger process will try to access the item held by another old transaction will be terminated. So what is the general solution of such a starvation? Aging. So you can promote the priority by what? Time, which is called the aging. So you can consider how many time is the overage, or when is the original starting time. So you can consider you can promote the priority, which means you can modify the weight algorithm, not just the starting, but originally when was the starting. When you restart the transaction, you can consider the original timestamp for to address the problem of the starvation. Timestamp, one more time, is not actually real time or world clock time. In the computer system, timestamp means it's a sequence number. So actually, for example, Oracle use SCN for the sometimes I mention the synchronized time, the match, which one is earlier, which one is not. At the time, it used just a sequence number. I cannot remember the sequence, something number, and it stands for a number. It's SCN. So they use something sequence number. That's the most important part to synchronize any operation or data. So if you take a look at log data actually keep such SCN number. Okay. So monotony increase the variable, mostly integer, but it's not actually the time. So it's the sequence number. Okay. We already see such a timestamp. So for the concurrency control, to keep the isolation level. So this one is a single, two-phase locking, actually the single version of the data. Like in the buffer, it has only one in place. But as we discussed before, the transaction management, we support the certain different isolation level. To support the different isolation level, I already explained about the multi-version technique. So we can adapt the multi-version technique with the timestamp also. That is called the multi-version technique based on the timestamp. But I'm going to skip this part. Okay. And there are different variants of the concurrency control based on, but they are based on the two-phase locking the mechanism. Okay. Okay, so that's the end of the concurrency control. Next class, I'm going to explain briefly about one more time this slide. Okay, for your reminder, then we will wrap up the class of the advanced database design, then we will have followed by the final exam next week, the Wednesday. Okay, so I too much speed up actually to finish on time. Any question today? Okay, thanks so much. Why don't you check your Canvas? If there's any problem or the issue, first contact the GA, then contact me. Then that should be resolved before the final exam. Okay, then after the final exam, I'm going to update the final exam score as well as the final grade together. Then next week Thursday, we will finalize all the grading report also. Okay, thank you, and see you on Wednesday. Do not miss the Wednesday class. Okay, I'm going to wrap up all the semester.